Okay, now let's try to generate this two series with same mean and standard deviation. First, let's look at a simple one. Okay, we have a sample return. We have 10 values, okay, from 2 to 11, 10 values. So we have the mean, calculate mean, right? It's the average of these 10 values. And we can calculate the standard deviation. And then we look at this with we assume this is a return, right? This here is a return. Here is a return. Yeah. And then we want to calculate what's the value at the end of this period. For example, we have this 18% return. So value at the end of the period, we get the 118%, right? And so on. So this is we have 10 returns, or 10 values. So we can calculate the final wealth. Final wealth. That's the multiplication of these 10 numbers. So this means if we invest $1 at the beginning of the period, of 10 time period, say 10 years, what we get is only 4 cents left. Well, 4 cents left. Although the average return is 6% per year. Now we look at this, say another sample, say just a quite standard sample, 1, -1, 1, -1. And so this is mean 0, right? Because everything cancels out. And the standard deviation is 1. So we want to, from this second sample, we want to generate this another series that with same mean and standard deviation as the first one sample. So first we time the standard deviation, okay? Here is a 0.351 to every number. So now the standard deviation is 0.351. The mean is still 0. And to make the mean same, we add this mean, right, to this series. Add this mean. Now we get mean is equal to same, right, 0.6%. And standard deviation is the same as the first sample. So what is our purpose? Our purpose is to show that although these two series have the same mean and standard deviation, if we invest in $1 in this two kind of pattern, their final wealth will be very different. And the one is here is 4 cents left. Here we get $1.03, right? Initially, we all invest in $1. For the first time series, after 10 years, we only have 4 cents left. The second one, get $1 more, right? So you see, even this have the same standard deviation and mean. The final investment result can be very, very different. But you know, in this portfolio theory, right, we in this mean standard deviation coordinates, the two investment, they occupy the same position in that coordinate system, but their final wealth can be very different. But then we can calculate a geometric return. The geometric return, the first one is almost negative 27%. The first one is I mean, a little bit above 0. So you see, with geometric return, we can distinguish them very easily. Okay, that's the advantage of this geometric return. And here you see that the second one, right, is quite special, right? Series quite special starting with. So now we do a one with second one is arbitrary. Say, let's do another one. Okay, another one here. The first sample is the same. Okay, the sample is same. The second sample, let's just write on another one. Anyone you can write on. And we have mean, we have the standard deviation. So the first step we want is to equalize the standard deviation. Okay, here the way to do that is we time the standard deviation of the first series, divide the standard deviation of the second series. So you see, now we get the standard deviation the same, right? Let's say we look at this one, right? We time the standard deviation of the first one and divided by standard deviation of the second one. We get this value. And then we want to equalize the mean. Equalize the mean is say we add the mean from the first series and the minus mean from this not exactly second series, but after this equalized standard deviation that's a series, right? Minus this mean from here, okay? So we can check here. So any number we plus that mean from the first one and minus from this let's say modify the second one. So now we get the same standard deviation and the same mean, okay? And now let's check. Final wealth, you see? Different, very different right? The first one is still 4 cents. Second one is a little bit higher than $1. So the first, but by geometric return, we can distinguish them very easily, right? The first one is almost negative 27%. The second one is, I mean, of 0. Right? So we can see their difference very easily.